Welcome to today's FDTD Satellite Applications webinar. Today we're pleased to have Caitlin Rutt from NWS WFO Amarillo, Texas joining us today. And the title of her presentation is Utilizing New Caps for Supplemental Observations in a Convective Environment. Next slide. Just a reminder, all these presentations are recorded, so if you miss these, just check the visit web pages. The URL is shown here, and you can check out past recordings. Also, we're looking for speakers. If you're interested, either contact myself, Dan Bicus, or Scott Lindstrom, and our email is listed there. Next slide. Just a reminder that we have about 20 minutes for our speaker. If you have questions, you can send them via the GoToWebinar question, and we'll also have a Q&A period over the phone at the end. We'll be done by 18:30 UTC, and just remember to do not press hold and mute when you're not speaking. So at this point, let's turn it over to Caitlin.
Thank you, Dan. So like Dan said, I'm going to talk about utilizing new caps for supplemental observations in a convective environment, and I'm specifically focusing on May 3rd, 2021 on the southern tier of Lubbock's CWA. So just to give a little bit of a synoptic overview, this is a 500 millibar chart for 12Z that morning. You can see that there is a trough present over the Four Corners region, and that was going to provide and did provide additional lift and ascent across West Texas through the afternoon and even into the evening hours. Looking at the 850 millibar analysis, you can see that there's a closed low over Northwest Texas, and that's what's brought a surface cold front through the Texas and Oklahoma panhandles and down through West Texas before it stalled anywhere between Lubbock and Midlands area. And you can kind of see that with the moisture profile. There was good moisture, decent dew points that surged in right behind the front. So that's going to be our source of extra lift at the surface for storms. Today, SPC did issue a meso discussion that day, and this was around 19Z. They were talking about thunderstorm development along the stalled cold front, like I had mentioned just a second ago. There were about 50 low 50 dew points right along and behind the front. They were expecting storms to start within the next hour or two. There were some agitated cumulus fields starting to form in parts of southeast New Mexico and West Texas. So just to look at the 20Z SPC mesoanalysis page, there was a narrow corridor of about 500 to 1,000 joules per kilogram of ML CAPE, and that was right along that frontal boundary. And you can see by that time the cap is starting to erode across the area as temperatures were warming into the mid to upper 70s right along that front. And then just north of that front, the temperatures were probably in the mid 60s, so it wasn't super cold behind the front. While further south near Midlands area, they were seeing temperatures in the lower 80s. As you can see, ML CAPE does increase further east into central and eastern Texas, and they did also have storms over there. So just had a narrow corridor over West Texas. And one of the big factors for instability was the 0 to 6 kilometer shear, effective shear. It was nearly 50 to 60 knots along that boundary, that surface boundary. So again, just a narrow corridor of good instability for storms to form off of. Along with the front, you got some isentropic ascent along the surface boundary. That's going to also lead to a potential storms just north of the boundary and potentially move northeast. And you can see the shear is also propagating northeast. Looking at the 20Z mid-level lapse rates, they're pretty modest lapse rates, good shear. Would set up an environment capable of producing strong updrafts and even large hail that day. Looking at the precipitable water, there was a chance with the front kind of setting up and stalling out, there was a chance that could see some flooding impacts. So there were decent PWATs, just under an inch across most of the area, and increased as you went farther east. With the stalled boundary, there were concerns of training storms that could create some flash flooding concerns. So this is the GO-16 visible satellite, and it did a wonderful job on the left-hand side of visualizing that frontal boundary position at which storms were later going to fire along, which you can see here through the loop, fire along this boundary in eastern New Mexico and even West Texas. And so as you can see, the environment was immediately behind the front, contained good low-level moisture that was supportive of these supercells. Another thing that you can see is in the north, kind of across the Texas Panhandle, more in Amarillo, CWA, maybe northern Lubbock, CWA, right behind the front, there was a good amount of low strata that did fill in behind the front that morning as it passed through. And that kind of put an end to the storm potential up in the Texas Panhandle for the Amarillo area that day. So we were looking at storms that day as well, but Lubbock got the show due to the front stalling out further south. The clean IR window, so the infrared channel, does a good job at showing these storms. You can see that they're not cooling as much as the storms in eastern Texas were, where the environment, there was much more CAPE over there. But you can definitely see in both the visible and the infrared, the amount of shear that was out there that day. You can see that the anvils were spreading quickly to the northeast, which is the direction that the shear was headed. So they were definitely being sheared. And along with, if you look close enough, you can sort of see the rotating updrafts and the fact that there were some strong updrafts present with level mesocyclones. So these were strong supercells that did form, strong to severe. So continuing along with kind of the GOES theme, you can see the day cloud phase distinction. This RGB is a product to see all different types of layers of the cloud. So one thing that it does show is the front and the low stratus and kind of the water clouds in that light blue cyan color. So that gives you an idea of where those clouds were in respect to the front and gives you an idea of where the front was as well. As you can see that there was some little bubbles of cumulus forming along the front. And then if you go further in time, you'll see that some of these clouds do begin to grow and glaciate, which is when they start to turn that kind of green color along the front. Started to see, more of those cumulus clouds, and that's when that MD was put out. And then as they continue on, the storms began to mature and they grew strong to severe, and that's when you start to see the bright orange, yellow colors, and that's when you know that you're getting a strong storm. And then on the right-hand side, just to go with the theme of the precipitable water, since we looked at the chance for these training storms, you can see they are setting up in a sense that they're going to potentially train as they come out of eastern New Mexico. GO-16's PWatts were showing an area of about 1+ inch, and that did increase with time and also as you moved farther east. So to compare the two, the GO-16 PWatts are actually slightly higher than those from the SPC mesoanalysis page. And that could just be due to also a fact that SPC's PWatts are in the lowest 400 millibars. It's not the entire profile, where GOES is likely looking at the entire profile, which is why it might be slightly higher in that sense. But overall, decent PWatts to give that chance for that potential for flooding. So moving on to the new caps. So there was about around 20Z time period. You can see this is the 2006Z radar scan, and you can see that there was a storm already popped up, and then there were a few storms popping up in eastern New Mexico behind this one. There was a pass from the new CAPS NOAA 20 satellite, and that gave us a chance to see the environment that these storms were kind of heading into. So unfortunately, there were no observed soundings done. The closest is Amarillo and Midland. And when I looked at the Midland 12Z sounding, it didn't really kind of represent the environment to the best of its ability, because these storms really did fire right along that front. So it wasn't that the environment to the south was better or to the north was better. It was the environment right there along the front where the dew points and low level moisture was surging was where the storms did the best. So there were three different points that I wanted to look at. So there's three soundings, and I apologize if they're a little small, but you can see sounding A, B, and C. And all of them came in around that 2030Z, so it was a little bit of a lag time. So that was right around that time when we're seeing storms intensify, and we just looked at the mesoanalysis for that. So we know that there is some sort of instability present. Unfortunately, with new caps, there is no wind. Satellite won't be able to give you the wind shear aspect of it. But as far as the Cape, you can see that there was a little bit of limited Cape. One of the things that new caps was struggling with that day was the surface temperatures. So you can see that the surface temperature in all three profiles is slightly lower than what the actual temperature was. So there was a little bit of a capping inversion with these soundings, but that was definitely broken as temperatures did warm, like I said, into the upper 60s, low 70s across the front. And so what it does show is that there was limited Cape, and we already knew that there was good shear. And another thing you can see is that low level moisture. And so if you look at sounding A, B, and C, all three of them pick up on that good, decent low level moisture for storms to work in. So one thing that's cool about the new cap soundings is this is a way to compare against models, but it's almost a better way of seeing the observation, the closest thing you can see to observation. I mean, it's a satellite scanning what's actually happening versus a model that is predicting. So it'd be good to compare this to a model, but this did a very good job knowing what the surface temperature is and kind of correcting for that. It showed a good example of what these the environment of these storms were headed into. So looking at a little bit more of a 2D scale. So with the profiles, you can then plot them in a 2D sense. And so I wanted to look at the gridded new caps 850 to 500 millibar theta E. So kind of your mid-level theta E. And this is the radar again. This is one scan later. So the storm, you can see, actually got a little bit stronger, a little bit higher DBZ core there. But really, these storms were kind of forming in a corridor of higher theta E, maximum theta E. And even the ones in eastern New Mexico that were coming in behind this storm were actually headed into that corridor as well. And that's a higher pocket of theta E, which kind of gives you a sense that there's greater potential of instability there. On the right-hand side, you've got your gridded new caps, and this is your sort of mid-level lapse rates, your 700, 500 millibar lapse rates. And you can see that this storm was headed into pretty much like a swath of decent mid-level lapse rates that matched pretty well with the SPC mesoanalysis. And so it was really kind of cool to see that this storm was headed into a good environment that was capable of supporting a strong updraft and even large hail. And you'll see, spoiler alert, you'll see later that there was large hail with these storms. But if we continue on and look at the gridded new caps total precipitable water, since we've been looking at that and the chance for like flooding throughout the event, you can see that the new caps was producing about over 2 inches of total precipitable water, which was actually higher than both of the GO16 and the SPC mesoanalysis page was showing. So the two satellites were actually closest in their estimates of PWatts, but it's kind of cool to see again that narrow corridor of where all that instability is where your higher PWatts are. And all of these storms coming from New Mexico and potentially the ones that are going to form later, all were going to ride along this area. And so definitely gave you an idea that there was a chance that you could get some heavy rainfall, training storms, and flash flooding concerns in that area. And then the last thing was the gridded new caps tropopause level. A lot of this is good for like tropopause folds, but in this case, it was kind of interesting to see your storms are moving as they move east. They're moving into a lower tropopause height, which sometimes can hint at the environment having more of a presence of buoyancy, increased buoyancy. And if you see, there's kind of a slope of these tropopause heights, which could be associated with, again, higher instability. So these storms are coming out of New Mexico into lower across the sloping. So there's a chance that you could have higher instability that these storms are headed into, just looking at that. All right, so what actually happened? This is a very, very slow radar loop, so I'll try to let it get through the whole thing. But this is basically, you can see storms began to initiate right along that front, all the way into, you had your storms off the New Mexico mountains, but then you had these storms in eastern, southeast New Mexico, all the way into West Texas, forming along this cold front, stalled cold front. And you can see that these did become severe. And they did sort of take on a train form as they rode along that surface boundary. And you can see the shear definitely present in this radar reflectivity being sheared to the northeast as storms ride along this area of good low-level moisture right behind this front. As it gets later into the evening, around 6 p.m., even later, so around this time, all this other precip and the storms that are going on now are actually being enhanced by that upper level trough that's coming across, and it's just providing additional forcing and lift and dynamics for the storms as they move across and move east. And we do remember that the environment was better as the storms moved east. So we did have the good shear, but the in the east. So overall, the event did have multiple hail and wind reports, as you can see with the SPC storm reports page. There are a few large hail, so 2.5 to 2.75 inch reports. And then there was a high wind report with one of the storms that one of the West Texas mesonet sites measured 84 miles per hour as the storm did move further east into north central Texas, where again, that instability was increased over there. And with that, that was all I had to show. And I thank you guys all for listening. And if you have any questions, I'm willing to answer.
Okay, any questions or comments for Caitlin? And I will open up everybody's audio in case you'd like to just speak. Oh, I see Brian Curran has submitted a question. Why would a lower tropopause height confer increased instability?
Good question, Brian. So this is obviously not always the case, but if you think of a sounding, sometimes if you have a lower tropopause, it may increase, so it shortens your sounding in a sense. It may increase your potential for increasing that cape presence, but that's not always the case, but it's just something that you can kind of take into consideration when looking at the tropopause height.
Okay, and then Brian Mata has a question, any lightning in this example, or did you look at the lightning? I guess that's what he's asking.
Yeah, so I did not look at the lightning. I wasn't super focused on those storms that day. I just had seen there was a new caps pass, so I had looked into that to see kind of what those storms were headed into. So I did not look into the lightning, but it would be very interesting to see the lightning presence, both with the GLM and with the gridded or the ground lightning, to see kind of what was going on, within the storms.
Okay, thanks. Any other questions or comments? Yes, we have another from Ryan Sharp. Do you regularly use new caps in real-time operations?
Yeah, good question. I actually really try to utilize it pretty well. I'm trying to get most of the Amarillo office to kind of get on board. But I did recently just do a little bit of HWT, and there's some really cool things I think that new caps can provide forecasters with to get you the next best guess, or even another eye of the environment and the profile of the environment as a whole compared to even RAYOBs and some models. So yes, we do use it, and I do use it. I do find things a little bit clunky in the sense of comparing. I would like to be able to compare the models, hand in hand. And I know that there's a tool coming out with SharpEye that can be utilized to do that. You could compare new caps with models and even observations and self new caps comparison. But yeah, I think overall it does a pretty good job. Obviously the surface temperatures tend to be off, and they're working on that with some modified soundings. But that's expected when it's scanning from space, and that by the time it gets to the surface, it's likely probably getting the lowest quality scan that it has. So yeah, I definitely utilize it, and I'm a firm believer on pushing it at all offices.
Okay, and Ryan replied, really neat to see the storms form in that peak instability area along the gradients. So he appreciates that.
Oh, thank you. Yeah, and that's exactly what I saw, and I think caught my eye the most and was worth sharing.
Okay, any other questions or comments for Caitlin? Okay, well, hearing no other questions or comments, we want to thank Caitlin for today's great presentation, and a quick reminder that this recording will be posted to the visit web pages, so you can share this with other folks that weren't able to attend today's live webinar. Thank you very much and have a great day.